Good afternoon. So, great honor to be here today. I've never been in Istanbul, and I think I'm now up past my bedtime, so if anyone, I'll have to grab some coffee afterwards, but wanted to talk to you a little bit about what NetApp's been doing around OpenStack, how we look at it strategically, how we're engaged with it, where we'd like to take it. The first place, of course, is taking NetApp's core competency, the things that core competencies, the things that we've done well that have allowed us to succeed to an extent within the market, and making sure that those capabilities are accessible in the OpenStack context, that some of the abstractions and service abstractions and intermediations that OpenStack presents don't hide the value and differentiated capabilities that NetApp platforms can provide, and indeed might actually be critical to the success of a given cloud deployment. So we've been involved in OpenStack actually since close to the beginning. These are some of the sort of thematic sort of categories that we're trying to unlock, bring sort of our core characteristics around efficiency, sort of the hardening, the ability to provide high SLA capabilities in a secure and sort of secure manner, provide unified storage capability that might be able, for example, to simultaneously support high SLAs in an OpenStack environment. At the same time, it's also providing critical storage infrastructure across underneath other stacks, maybe indeed is a means of facilitating movement from one to the next being, as we expect, OpenStack. So NetApp, as I mentioned, has been involved since close to the beginning of OpenStack. We were there within about 6 months of inception. We're the first major storage provider to have provided upstream integrations, and that is our strategy by default, is to make sure that our contributions, if at all possible, go into the open source itself, into the upstream, such that regardless of which distribution you might want to use, or if indeed you actually want to consume it directly from upstream, NetApp's capabilities exist within it. We've been, I think, sponsors of the last 9 summits. We are also I'll get into a little bit more detail about this in a minute. We're the founders of a project called Manila. I'd like to talk to you a little bit about why we think that's significant and where that's headed. We are ourselves also a deployer of OpenStack, and this is still in just beyond a formative stage. It's still in a building stage, but we're intending to move, at least in one particular site, a location where we have over 40,000 virtual machine instances, and moving that in its entirety to OpenStack. And we've actually got 2 major IT organizations at NetApp, both of which are headed very heavily down the OpenStack path. I mentioned also, or I didn't mention, we are charter members of the foundation at the gold level, and to the extent possible, I think I mentioned this already, we try to provide our integrations within the community rather than introducing a proprietary capability that you have to download and perhaps would be licensed to you separately. So I just want to talk a little bit about OpenStack deployment. I've spent 4.5 years working with OpenStack, and for a long while we got questions of, well, when will this start to arrive? When will we start seeing a critical mass of adoption? I'm not sure that I'm ready to say that it's fully sort of ready for every sort of definition of IT customer. There are those who, if you will, expect sort of an enterprise polish, determinism, support, and whatnot. And those things are, I think, best derived through the distributions, through the efforts of the distributions of OpenStack. But in the general sense, speaking of the whole of it, it's grown significantly. This is just the last year, and this is based on telemetry that we can actually measure on NetApp systems. So we've seen a pretty significant growth in the number of folks actually moving to production deployment. So again, this is empirical data measured from telemetry we get from NetApp systems. We know if the deployer elects to provide the telemetry, certainly from a privacy perspective, you can elect to turn it off. We know that there's been a pretty significant ramp in those who are actually moving from POC directly into production. But even more significantly, and I think as a testament to it having arrived in some ways, we're seeing a really dramatic growth in the number of deployed systems, which we've extrapolated, we've interpreted to mean Now you're actually adding additional capacity for organic growth to meet production needs. This is no longer like stuck in a lab. This is actually starting to underpin production deployment. So I do want to talk to you a little bit about like sort of the backdrop for NetApp's efforts and what we're trying to achieve in the broader sense. So it's probably been established in some of the earlier sessions, I think maybe generally held, that there's not just one cloud. There's many different cloud providers with different and disparate cloud services. In the North American market, certainly, Amazon Web Services has a very significant presence. There are other large, at least in NetApp terminology, we call hyperscale providers. We see a number of folks doing hosted private cloud. We see folks with kind of a different differentiation sort of approach. Maybe things that haven't been fully commoditized but are built on kind of common standards. The point is, it's not necessarily one cloud that you're interacting with. I know that in our NetApp corporate IT, we did a survey and looked at whether we measure it as infrastructure as a service or software as a service, whatever your definition of a cloud capability might be. We were doing business with a couple hundred different companies. And that may be extreme, but it's not one destination. And so the question is how do you move data between these different locales? We think that at NetApp we've got a strong foundation for facilitating the most efficient movement between these different locales. Indeed, the intention is to build a common data fabric that underpins it. So the platform within NetApp's portfolio that's most commonly associated with the NetApp brand is run with, there's an operating system called Data ONTAP. It's our filers. That actually is not, NetApp's not the largest storage company in the world. We're certainly not claiming that. But that's actually the most commonly deployed single commercial storage operating system in the world. So it's a good place to start building out this fabric. We've got over 200 service providers around the world. I'm not claiming those are all on OpenStack yet, that have built out cloud services in some form or another on NetApp underpinning. So again, you can start to see that we have some of the foundational elements to build this. This is an expression of where we're going. I'm not saying that NetApp has the common data fabric ready for you to purchase, but we have the elements of it in place, and we're building significantly in our development effort towards this vision. So where we see OpenStack is playing particularly an important role is providing a common API set. To the extent that OpenStack is widely deployed and becomes more and more ubiquitous, then you can start to rely on OpenStack, the OpenStack API. And actually here, you'll see that I have it denoted as OpenStack 2015.4. That is a specification. That is actually expressed by the community as a specification for essentially API interoperability, API compatibility. This is part of the DevCore effort, I think, that possibly Jonathan may have alluded to earlier. So whether it's you have something deployed on the yellow cloud and you want to move it to the purple cloud, if you have your application logic written against this particular specification, you can ensure, you reasonably expect that you're going to have a common infrastructure as a service operating environment. And so when you start looking at that on top of this common data fabric, you're going to get a little bit closer to I think the as of yet unrealized true promise of hybrid cloud. This is not the only way we see OpenStack, but we see this as a pretty significant measure in achieving sort of our nirvana state of movement around into these endpoints as to your taste, based on perhaps economics, based on security requirements, based on particular SLA requirements, but ultimately you choose, and this will be the underpinning of it, we think. So I just want to talk a little bit. I'm not going to go through all of these, and I don't expect everyone knows it, but these are the 5 major sort of platforms that exist within NetApp's portfolio. An object storage capability, sort of a cloud backup and vaulting capability in all flash native array. We have a dense, high throughput set of systems called ENEF series, and the Data ONTAP system I already alluded to. And our intent is to try and provide a strong integration from the more data-centric OpenStack services against each of those. And so certainly above the line, you'll see intentionally trivialized notion of some of the more common OpenStack services that have heavy data storage requirements. And I just want to show you briefly where some of that actually maps to. I'm happy to answer any of us with NetApp are happy to answer some of the, if you have any more detailed questions about the nature of this integration. I'm just going to highlight a few of the areas here in a second. but I'm not going to cover it all. So these are where, for example, Glance and now here's Swift, what these map to, Cinder, Nova, and Manila. And so if you're not familiar, you can do sort of the color matching. We're talking about the image, shared files, block storage, object storage, and generally compute services, and how those sort of map to those storage platforms. So let me get into a couple of examples of what we've done. So you take, for example, on the case of Cinder, some various NetApp storage platforms. We provide diverse set of means of connection for each of them, and have introduced new capabilities. We provide the generic NFS driver for Cinder, and then of course we've also provided NetApp specific versions of it. But likewise, we support other block storage protocols as well, and here's the listing. One of the things that we've tried to influence within the community, this has certainly been a collaborative effort, not NetApp alone, but that we've been instrumental in, is evolving the notion of kind of a catalog or maybe a storage marketplace, however you want to call it. But the ability to define arbitrarily, well, not arbitrarily, but it's per your taste. It's not a hard construct. You can establish what makes sense in the way of tiers for you. Perhaps it's gold, silver, bronze. Maybe it's dogs, cats, birds. Again, whatever it is that makes sense that you want to provide to your tenant base, and allowing you to map these back-end systems behind a common service layer and create this catalog of capabilities that align to the service, the underpinnings behind it that can best meet the needs. Perhaps for a more of an analytics workload, you'd use like a high throughput capability like the EF series, or perhaps with more of a streaming workload, the FlashArray system would be most appropriate. But from a cloud tenant perspective, they know nothing about what sits on the other side of it. They know everything about this catalog that's presented to them, and then Cinder coordinates the activity of providing those block devices with the characteristics that are so desired. So this is a way that we're able to take those unique characteristics of our systems and make them available to the tenant, even if OpenStack itself doesn't have a strong sort of notion of what those things are. So another example of this is when you take, like, for example, the combination of Glance, which is the image service in OpenStack, and Cinder for presenting new instances, guest virtual machines, Nova virtual machines. We've done some enhancement between the two services that allow you to create those using our cloning technology, so you don't have to copy it. So it happens essentially instantaneously, and they're persistent by default. For some of those workloads I think have been referred to in some of the prior sessions that maybe are sort of fully cloud native and you really don't need that persistence, well, that's simple flag, delete upon terminate. So you can get the best of both worlds. Likewise, we can apply NetApp capabilities like deduplication on top of Glance, and we get up to 90% deduplication rates in the first place. So you never even necessarily had to consume that additional space. It actually has, as an artifact, some performance benefits as well. Just a couple of examples of some scenarios, different Cinder providers, where you see a really dramatic improvement in performance in creating new instances. And this actually happens to scale. This becomes a more significant factor as the scale of your deployment grows. So I do want to talk briefly about Swift. I'm certainly not going to go through each of these bullet points. But Swift, of course, is the object storage service. I think the thing that's probably most unlike a lot of the rest of OpenStack, and if you permit, I guess my sort of crude definition of a lot of OpenStack services is it's a way of knitting infrastructure primitives into a collective and availing it, sort of a by common sort of modern definition of interaction points, a la a RESTful API, accessible through, in this case, the Horizon web front end, has a command line interface. But the point is it's not necessarily actually the full implementation. It will typically have a reference implementation, but it tends to be a service framework. So Swift is unlike that in that Swift is the actual data storage server. It's the thing you do puts and gets against directly. So we, of course, have actually taken the upstream Swift project and actually provided a reference architecture to sit it on top of our E-series systems. And without going into a tremendous amount of detail here, the effect of it is that you can reduce the amount of capacity you need to protect data by a factor of almost 3. And that's with minimal modification to Swift. It's just based on an inherent quality of our E-Series systems. We also have a product of full stack object storage capability called a full object storage stack capability called Storage Grid Web Scale. And we're in the process of actually providing Swift API support. So in this case, it is not Swift, but it provides an alternative Swift implementation. So if you've written applications against the Swift API, it'll function against Storage Grid Web Scale. It'll also use Keystone in the release coming later this year. So the thing I'd like to focus on just a bit is something called Manila. So these numbers are actually a couple years old. I haven't been able to find newer ones, but IDC indicated that of all the commercial storage sold in the world, I'm not referring to disk drives for consumer systems, but for enterprise needs, enterprise and like service provider needs, 65% of it was actually to underpin shared file systems. And that's a fairly significant amount when you consider that up till recently, OpenStack, and for that matter, any other major sort of cloud capability didn't have explicit treatment for shared file systems. So I think we've solved that, the community collectively, in the way of a new project called OpenStack Manila. And it basically is, if you're familiar with Cinder, it's Cinder but for shared file systems. So it's a way of taking like a diverse collection of perhaps requesters, a diverse group of folks that you might want to provide a common access to a shared file system, and it coordinates the entire activity. It could create a net new share. It can provide access to one that already exists. It maps it into the user namespace and auth authority. I'll go into a little bit more detail on that in a second. This has actually been around since June of 2013. And it's interesting because now we're finally starting to see some of the other slower moving large cloud providers out there to following suit. Of course, that's meant to be a joke, but it is an interesting example where OpenStack has led and Amazon Web Services and Microsoft Azure have followed. So this is a project that is ready for production-like capabilities now. It's not completely done. But I'm going to go through a couple of examples of folks who do use it. Oops, sorry, a build problem here. So here's an example where Manila could be used to provide common access to a marketing share between a couple of virtual machines. Maybe it creates a net new R&D share. Kind of that same catalog construct that I talked about in Cinder also exists in Manila. But this could also actually be used, and apologies for these broken builds here. But we could also actually coordinate that access to that same shared file system across containers, across bare metal entities, across virtual machines. And this is a real capability today. It's not really, the substance of this demo isn't all that important. It's just more of a measure, hey, this actually exists, is real, is functioning, and actually is being deployed in a few cases. So I just want to talk a little bit about some of those examples. Some of these folks actually joined us at the OpenStack Summit in Vancouver, I guess a week and a half ago. Talk a little bit in more depth, so if you're more interested in this, there's full treatment of these topics on YouTube. I'd be happy to refer to you afterwards. Thomson Reuters actually is probably one of the first public examples of production usage of Manila. This is to provide a utility database as a service capability internally and also for hosted tenants. This is rolling out to, I think it's something like 14 different locales globally. Another example that Deutsche Telekom got up, and I don't want to claim that this is actually in production, but they did an evaluation. Actually, they're collaborators within the Manila community to actually evolve it, and they have an intent of moving their vast quantity, basically 20 petabytes plus of shared storage systems, shared file system storage, to Manila model as it starts to mature. NHN Entertainment, they're actually, just to be clear, not a Manila deployer as of yet, but they're kind of an interesting scenario around that hybrid cloud promise we talked about earlier. They actually will deploy like a gaming title out to the public cloud and repatriate it to on-prem for reasons of economics. Basically, it's much less costly in certain sort of workloads to own versus rent over time. And OpenStack actually makes that possible. But getting back onto the Manila track briefly, University of Melbourne, another early deployer of it. NetApp's own global engineering cloud I talked about already. One particular location is 10,000 VMs. That 40,000 I alluded to over prior, I'm sorry, was actually a few different locales in aggregate. Manila is not strictly a NetApp activity. NetApp actually identified the need. We put a lot of investment behind it. Myself and another individual happen to be the co-founders of the project, but it makes for interesting times within a company when you have to go tell your executive management, I want to go invite my biggest competitors to the party. And the point is that in doing so, we're able to actually facilitate legitimacy. We're actually able to deliver something that is going to meet muster within the community to be elevated as a project that's not so strictly identified as only one vendor driven. So some of our biggest customers are actually participants. All the folks in italics here are new additions in just the last development cycle. And I'd be happy to answer more in-depth questions about this. It looks like I'm running out of time. We've got a bunch of additional stuff targeted in the next Liberty release, or in the next release, which is the Liberty development train. I guess the thing I just kind of want to underscore with this, our big push is to make Manila fully ready in kind of the commercial 1.0 sense at the end of Liberty so that you can actually reasonably use it even if you're not necessarily comfortable with some of the harder edges of some of the other earlier stage projects. NetApp does not actually go alone in the OpenStack ecosystem. There are a number of folks that we partner with. This is certainly not an all-inclusive list, but amongst the distribution providers, we have explicit relationships and done some additional work with the Red Hat installer, the Marinus installer, SUSE installer, the Red Hat private cloud software installer. Likewise, on reference architectures, we've done some work with all the ones listed there. In particular, we're just talking about Ubuntu. And then around automation, have done some platform enablement around Puppet and Chef and looking to do the same with Ansible here in the coming months. An example of this is Red Hat has announced actually in the last couple of weeks that they will be the first, I'm not sure that they'll actually end up being the first, but they were the first to announce that they will provide Manila in technical preview form in the next release of Red Hat Enterprise Linux OpenStack platform, RHEL OSP. Likewise, we've also talked to a couple of other larger distribution providers, one of which is already committed to actually provide it in their next release, and the other has indicated they will, but it might be in the release thereafter. So this is going to be critical in actually getting it sort of fully ready and done and make it more of a standard. And this will be probably the best overall means of consuming Manila services. An ultimate expression of this may be if you really want kind of that easy button, we are in the process of collaborating with Red Hat and Cisco to deliver a OpenStack FlexPod, if you're familiar with that converged infrastructure platform. So that's not yet out in the market, but validation activity should be complete in the coming months. Look for news on that. Just to sort of wrap, just kind of recap some of what I was attempting to express. We have a broad portfolio of systems, and those platforms are well integrated with OpenStack. We've had a long-standing commitment to the community. We default to providing upstream integrations. We have a diverse set of ecosystem partners, and again, that was not an all-inclusive list. And really the intent is to try and bring like the characteristics of our systems to OpenStack so you can achieve an effect greater than the sum of the individual parts. And all in the vein of trying to build towards this common data fabric, wherein I think OpenStack plays a critical role in ultimately facilitating that. So just to get started, netapp.github.io, good place to get at our deployment operations guide and reference architectures. We will be in Tokyo, so look forward to seeing you there if you happen to make it. And likewise, there's a bunch of folks here in the room and in the lobby from NetApp if you have any other questions. Thank you very much. Appreciate the time.